Hey everyone. I hope you all survived yesterday's Halloween parties and can stick with us for these demos because we have a lot of demos to run through. So the next version of Unity that we're going to ship is 5.5. We've been cooking on it for quite some time already, and as usual, you can get the latest beta version from our website today. We're going to dive straight into the demos. Actually, first I'm going to say that we're going to look at a few demos that show what Unity 5.5 can do right now. And we'll also have a few demos that look a bit more into the future to see some of the things that will be coming down the pipe later on. So we're going to dive straight into the demos now. And we're going to start with the demo from Filip Iliescu, who works at Unity to support their Apple platforms, to talk about the state of metal rendering in Unity today. Are you, Filip? There you go.
Thank you, Lucas. Hi, everybody. I'm Filip Iliescu, and I help our Unity developers be successful with our platform partners. Now, I'm super excited to be here to share this update on Metal within Unity. As John mentioned earlier, mobile graphics are top priority for Unity, so we're pushing really hard to bring you the best mobile graphics engine in the world. Now, at WWDC this last year, we showed this demo of Metal tessellation running with compute and native metal shaders. Today, I'm going to show you a new demo and talk a little bit about how we're planning to roll all these features out. Let's pop over to the demo machine here. And all right. So starting in Unity 5.5, we've upgraded our shader cross compiler, which opens the door for many advanced graphics features and instancing in native metal shaders. So here we have this demo running, and you can see with instancing not enabled, it's running at about 2 or 3 frames per second. It's running very slow. But the minute we turn on instancing, we'll see the performance dramatically increase. Now, instancing is the case where you're running many similar game objects with only a single draw call. So essentially, what we have here is about 12,000 asteroids. It's we've sped it up to about 30 frames per second, and for those of you not familiar with instancing, basically we're rendering a lot more objects here, and each asteroid is animating independently with its own color variation, and they receive and cast shadows on each other. Notice that this would not be possible with just batching the asteroids together. Now, I have just one more thing to share with you here, so I'm going to switch over to the Mac. OK, here we are in a preview build of Unity, and notice it's running Metal. So that means that you can get instant feedback on anything that you might be doing before you deploy to device. So real quick, instancing is very easy to enable. You can simply enable, change the shader on the game object that you want to enable. One line of code in the shader. It's very simple. So I'm just going to go ahead and hit play and just show you some of the things that you can do here. Very simply, you can sort of adjust the number of asteroids and see that instantaneously. You can pop over to the camera. There's a lot of things you can do and just get immediate feedback before you actually deploy to device. I think it's going to be a huge win for people and just really save a lot of time. We're really excited to launch this more complete workflow for Metal, where you can immediately see your modifications to your compute shaders, post effects, native metal shaders, or any game experience targeting any Metal device. To get early access to these features, make sure you join our beta groups and forums and watch for announcements. So let's switch back to slides for just 1 second. I wanted to bring up this, this timeline here to show you sort of how we're planning on rolling these features out in Unity. In 5.5, we've upgraded our shader cross-compiler, which basically opened up the door for instancing and native metal shaders. And it also opened up the door for compute in Unity 5.6. Later in 2017, we'll bring you tessellation and the editor as well. But that's the timeline. That's what we have to look forward to. So yes, please join our beta groups and keep apprised of announcements. Thank you very much.
Philip. So over the last 2 years, Unity's graphics capabilities have really been taken up, to another level. But what good is all this graphics performance and rendering capabilities if you don't have great content to use it for? So a new area that we're going to spend a lot of energy on at Unity and have already been putting a lot of effort in so far is artist tooling. Now, artists from the movie industry, they are used to, they have to their availability a wide range of really amazing tools to help them output their creativity. But if an ambitious artist from the game world tries to use some of these movie tools, they quickly run into the problem that there's no convenient pipeline between the two. That in games, you need to do things slightly differently, and these tools don't, they don't help you with that very well. So we've been working on a tool that attempts to bridge that gap, and I will show you it in a demo right now. So right here, I have my Viking Village demo. And I have a particle system here. And what I want to do is I want to spice up the smoke animation. Now, a tool that's very popular in the movie and VFX industry is a tool called Houdini. And we've used Houdini to create an explosion animation here. You can see it here. It has all these frames. And this is actually already the point where you run into a problem that, in games you want to do things slightly differently than in movies, because if you want to render an animation like this efficiently in a real-time engine like Unity, you want to have all these frames in a single texture sheet. So we've made a tool that should help with that, and let me show you how it works. I'm going to go here, I'm going to go create VFX Toolbox image sequence. I'm going to double-click it. I'm just going to throw my explosion folder on there. I'm going to hit play to see what it looks like. Oh, let me go back to color mode. So this is the animation. And I can go to processors here, and I can add a processor and go to assemble flipbook. And what it will do is it'll give me this 5x5 texture sheet of the animation. Now, the original animation, it was actually much longer. And you can see that because we only have the first 25 frames with the fire and none with the smoke. So instead of having to go back to Houdini and do another time-consuming export, we made this tool so that you can fix that in Unity right here. So let me go to the processors again, and let me add a read-time processor at the top. And I'm going to tell it that instead of whatever frames I have now, I want to have 25 frames, and I don't want to use this curve thing here. If I now go back to the flipbook, you can see that now it has resampled the whole animation so that the whole thing fits into these 25 frames. OK, so let's take a look. Oh, actually notice that it's 2K by 2K here. Another thing that's slightly different in games, because in games we like things to be power of 2. So let me add a resize processor at the end here to just turn this guy into a 124 by 124 texture. When I like it here, I'm going to go to export and hit export as new. And we'll call it thick smoke. And it creates this texture for me right here. So let's see what this looks like in the scene. So I'm going to go back to my particle system. I'm going to tell the particle system to use this new texture, which is going to look super weird, because we haven't told the particle system that this is an animation. So let's do that and turn it on like that. So since all these demos that go very choppy in the beginning and then smooth get all this applause, I've made one too. Well, let's wait till let's wait and see if I can actually get it to be non-choppy before you start with the applause. So typically what you would have to do now is go back to your authoring package and do a re-export, because these 25 frames, it turned out to really be too aggressive. We need maybe 50 or 60 or 70. However, we can do that in the image sequencer here. So I'll just go back to the processors and to the read time. I'm going to tell it that I want 64 frames instead of 25. And then at the flipbook, I'm going to say that I want to have 8 by 8. So basically what I'm doing here is I'm sacrificing resolution per frame in the texture sheet in order to be able to stuff more frames into my texture sheet. So you always have to find a balance between these two. But it's still a little bit sad that we lose that resolution, especially because when you turn on the alpha here, you can see that we're doing a really bad job at efficiently using the texture space, which we actually pay for twice, because you both have this wasted texture space, and you also pay for the overdraw when you actually render it. So again, same story. Instead of having to go back to Houdini, we can do this here in the tool. I can get a crop processor. Here it is. And I'll put it over here. I'm going to find a frame that's sort of the biggest one that still needs to fit. Let me enlarge that a little bit. So I think the largest frame is kind of this one. So I'm going to give it a much tighter fit now. I'm going to crop it to the top and the bottom, the left and the right. I've done this so many times. I've become an expert cropper. I'll go to Unity Connect actually and sign up and have cropping be one of my core competencies. If you ever need a cropper, you know where to find me. So I think all the frames fit quite well into this. Oh, look at that one. It gets a little bit cut off. Let me ease up on that a little bit. OK, so now I go back to the bottom one, and you can see that we have a much more efficient texture utilization. So some of the resolution that we had to sacrifice to get these 64 frames, we've been able to win it back. OK, so now that I like it, I'm going to go back to export and just hit update. It's just going to override the same texture as before. I'm going to take a look in the scene view, and beware, because it's going to be all screwy again, because the particle system still thinks this is a 5 by 5 thing. So let's tell it that it's an 8 by 8 one, and there you go. It's much smoother and looks pretty good. Maybe I should have made it even more choppy in the beginning for like the punch. All right, so I'm happy to announce that this tool, which we're calling Image Sequencer, you can already get the first preview build of it today at unity3d.com/experimental. So please go download it, try it, and tell us what you think. I think it needs Unity 5.5 Beta 7 for it to work. And we're very happy that we've been able to get that into your hands today. Now, another area where artists in the movie industry have been way ahead of what you can do in games is post-processing. And at Unity, we've had a post-processing team that's, for the last year, been working to create a new post-processing stack that's fast and really powerful. And we took a very good look at the tools that people in the movie industry use to make sure that all these controls and all this experience of how to do really kick-ass post, like color correction, tone mapping, to bring those same kind of controls that artists in the movie industry are used to bring those to Unity. So for our next demo, we're gonna get a demo from Matt Dean, who works on Unity's post-processing team, to take a look at all the stuff in Unity's post-processor stack. Take it away, Matt. Do you need a slide? Oh, you don't, right?
Hello, everyone. So this last year, we've been working on a completely new range of image effects to help make your products look their best. As we closed in on a complete set, we started looking at the next step. So that's what I'm here to show you, our new post-processing stack. We've combined the full set of individual effects into an easy-to-configure, asset-driven workflow. What used to take at least one full-screen pass per effect now takes significantly fewer passes. So post-processing is now faster and easier than ever before. Of course, we also have some new and improved effects to show you. So I'm going to start with improved chromatic aberration, eye adaptation, brand new depth of field, and improved bloom with lens dirt. But that's just the beginning. So let's dive into a scene and have a look at a proper use case. Here we have a scene from ArchViz Pro Volume 3 from the Asset Store. And we're just going to have a look at applying some post-processing to this. First, we're going to take a look at our color grading. Let's say our artist had gone in and made some changes to this that we didn't really like, and maybe we'd have something that looked a little bit like this. This problem is really easy to fix with post-processing. So the first thing we're going to look at is the scene's luminance. To do this, we're going to use a monitor called the histogram. The first thing you're going to notice is that all of our values are right up in the top end of the histogram, meaning our scene is way too bright. We can fix this easily by adjusting white levels to push everything back into the range, adjust the black in and out, to just rebalance our scene and get a nice exposure. The next thing we would have to look at is the color. To look at this, we're going to use the vector scope. The vector scope is a circular diagram that represents all of the hues that could be found within our scene. The exterior of the vector scope is higher saturated values, and the center is monochromatics. As you can see from the vector scope and the game view, we have a pretty heavy green tint here. So I'm going to fix this using our log trackballs. As I adjust the trackball, you can see the black areas that represent the hues that can be found within our current camera view realign themselves towards neutral, and we fixed our tinting simply. The next thing I want to show you is our brand new depth of field. As you can see, it uses realistic camera controls, which make it really intuitive. If I turn on our focus plane debug, you can easily see our focal point and the width of our aperture. If I narrow our aperture, it's very simple for me to adjust our focal point. I can then re-widen, disable the debug, and just adjust to taste. That's how simple our new depth of field is to use. Moving on, I'd like to talk about edge quality. Here you can see that without any form of anti-aliasing, we have some pretty jagged edges. However, if I use our new temporal anti-aliasing, you can see that not only are our edges smoothed out, but this is lightning fast. We've tested our new TAA on PS4 at 1080p, and it comes in at under a millisecond. The great thing about TAA is that under movement, because it collects all of our frames in a history buffer, it keeps all of our edges smooth, even in motion. At this point, I'm just going to start throwing on some other effects. And once we're happy with our color grading and all of our effects, we can move on to the next step. Because this is an asset-based system, we can easily apply the same post-processing to multiple cameras. At this point, I could adjust any of our values in our post-processing, and it would update in real time, in play mode, on all of the cameras that it was assigned to. If I disable our post, we can see just how much difference this makes. Just like we can use the same post-processing on multiple cameras, we can also easily switch between different post-processing on the same cameras. And there we have it. Simple to use, industry standard post-processing in Unity today. Thank you.
Woo! Thanks, Matt. I love it. Actually, one of the great things about this post-processing stack is that it's open source. It's a bunch of C# scripts and shaders, and we're actually nearing the end of our beta phase, and you can get the bits from our GitHub today to use this stack to up the level of the graphics in your game to a new level. Can you say that, up a level to a new level? I don't think so. Actually, I'm sure they'll hate me say it, but I'm super proud of what Unity's post-processing team has been able to achieve for our customers this year. We really it's really an amazing improvement in graphics for Unity in this past year, and we're really hoping that you'll use it to improve your graphics. If there's one area in particular that we are very aware that we have some work to do to earn that artist love, it's the area of light mapping. I guess that's applause from some people with scars. So we've been at work at adding much more artist workflow-friendly light mapping tech to Unity. And as usual, when we develop these kind of features, we make sure that very early in development, we include a bunch of early teams to use the feature to make sure that we're doing the right thing, to tell us if we're actually solving the right problem, if we're going into the right direction. And one of the teams that's been helping us find the direction for this light mapper is here with us today, and they're going to show us a demo of what the light mapper can do, how it works, and how it has changed their art workflow. So please help me welcome to the stage Juan Martinez from Playful Corp. Hey, Juan, do you need the clicker?
Yeah.
There you go.
Hi, everybody. At Playful, it's our passion to create fun and cutting-edge games. Our first game was Lucky's Tale, and people really loved Lucky's immersive and happy world. But when we were making that world, light baking was a huge bottleneck. So I'm really happy to show you the new progressive light mapper and to give you a sneak peek at what we have cooking over at Playful. So this is a new scene we have in development. To enable the new progressive light mapper in the lighting panel, turn on Bake GI and pick progressive from the Bake backend dropdown. I'm going to turn on auto mode, and let's focus on this small section over here. So progressive rendering is at the heart of the new lighting engine. The longer we look at this scene, the progressively better the render is going to get. Let's pretend I forgot to enable my main directional light. So usually, this would cost you several hours of re-render time. But as I enable and disable the light, see how the viewport instantly updates and starts progressively rendering again. So my favorite new feature, though, is prioritize view. Notice as I rotate the camera around, whatever I start looking at is what takes priority in the render. So anywhere you focus, we'll start rendering right away. In many ways, this is better than the old bake selected option. So I know what you're thinking. Progressive rendering works great if I'm looking at a small part of the level. So let's take a bird's eye view. And I'll open the Light Maps tab. So notice as I rotate the main directional light around, the entire level instantly starts rebaking. Any changes you make to a bake light, color, intensity, and bounce, will automatically start rebaking, and it'll give you a really good idea of the final output. And I also think it's really cool to see the light map textures generating in real time. I'm going to turn off auto mode and clear my current bake, and then hit the build button. So let's say that you need to make a build right now. you've been rendering for a little bit, and you're really happy with how it looks, the new Force Stop button lets you stop the bake, save the current progress to disk, and you can make your build. And then when you continue baking, it'll pick up right where it left off. Another great feature is the new ETA in the bottom right corner of the screen. Yeah. So, previously, we'd wait for several progress bars to finish, but you didn't really have a clear idea of how much time the bake had left. Here, we can see we have about 24 seconds for this entire level to finish baking. But before it's done, let's open up the baked lighting view, and I'll head over to this small section over here. So this is an area of a bunch of complex intersecting objects. What's really great about the progressive lightmapper is it doesn't need a third UV channel, and it doesn't break your model up into extra UV charts. So you can expect to see fewer seams and fewer shading artifacts. So the bake's done. I did time that really well, actually. So I'll go into play mode now. All the lighting options are either in the lighting panel or on the lights themselves. With such a small learning curve, anybody on your team can do lighting. So let's take a look around. I think for just a couple minutes of baking, that this looks really good. So with iterative tools like progressive rendering, prioritize view, force stop, and the new ETA, it makes doing lighting fun and playful. Thank you.
Thanks, Juan. Thanks, Juan. And thanks for all the early feedback on our builds. So the light mapping team is not quite ready yet to push out the first preview build, but when they do, it's going to arrive at the same URL, unity3d.com/experimental. So please keep a lookout for it so that when we ship the first bits, you can get your hands on it.